Welcome to your own channel of Right Funda. Here is a question from laws of motion. Some students have asked the doubt. Let's go through the question. It says, as shown in diagram, there are two blocks of mass, same mass capital M, one on top of the other, lying on the frictionless horizontal surface. Both the blocks are at rest. The upper block is much smaller than the lower block. The force capital F is applied on the lower block and both the blocks starts moving together without any relative motion. Suddenly, the lower block hits a fixed obstacle and comes to rest. The upper block continues to slide on the lower block. Question asking, the upper block just manages to reach the opposite end of the lower block, then what is the coefficient of friction between the two blocks? So what question is saying, there are two blocks were there, and this block and this block, two blocks were there, and you applied some force that they moved together and came and they hit this obstacle. After they hit the obstacle, this comes to rest. This continues moving, and after the time it comes to near the obstacle, it stops here. So find the what is the coefficient of friction between the block and the other block or the plank. These two lengths are given. L by 2 is the length of plank, and the plank's right end is at a distance L from the left end of the obstacle. So once you understood the question, now you can try, you can pause the video, and I'll be discussing the solution right now. Okay. So what will be happening? Let's see. So question is saying that there are two words is there, that the friction is there between this. There is no friction here. There is no friction here. No friction. But between this, there is a friction mu. Coefficient of friction is mu between this. Okay. And the question is saying that both the block, as you apply the forces, both the blocks starts moving together, it is saying. So meaning thereby the friction is sufficient so that relative motion is not happening. So these two can move together. It is given the question. So if I draw the free body diagram of these two systems together, because as they are moving together, so there is no harm in taking their combined free body diagram. So I will take their combined free body diagram. Then the combined free body diagram will look like this. So suppose this body upper block has a mass m and this is having a mass capital M, and I am applying a force F on this. So this two body will go together. So net external force, this force becomes internal force. There is no friction in this place. So in the horizontal direction, I have drawn the diagram. The only force is the F force, external force is the capital F force is acting. So I can write the equation motion F is equal to total mass of the system into acceleration. So from there I got the acceleration is equal to F by small m by capital M. But in this particular question, it is given that small m and capital M both are equal. Their masses are equal. So if I substitute this one and take both the masses to be equal to small m, I got acceleration of the system of both the blocks is come out to be equal to F by 2m that we obtain. Okay. Now, so these two blocks will keep on moving with the same acceleration. Keep on, till what time? Till the time they will go and strike this obstacle. Till the time only this is the external force is acting. So before striking the obstacle, what will be the velocity of the lower block, or the same thing is the velocity of the upper block? So both the combined block, what velocity they must have been attained, that will be calculating this one. So we apply the formula v square equal to u square plus 2as, and initial velocity was given at the rest. They started from rest 0, and the acceleration that I substituted here. So I got the velocity after traveling a distance of L, because this from this end to this end traveling a distance L, what will be the speed of both the blocks combined. So from this I can simplify this one. I can cancel this 2 with 2, and this we can calculate the velocity speed just before striking will be equal to v is equal to under root of fl by m, under root of fl by m. That another result we obtain. Okay. Now, so this is the velocity there. Then what will happen? As soon as this block hits this one, as soon as this block, this lower block come and hits this one, a large impulsive force will act on this, and that will bring about a sudden change in momentum of the lower block, and this come to rest because of the large impulsive force, very large force acting for a very small time. But there is no impulsive force on this, so that practically the momentum of this will remain unchanged. So whatever velocity it has attained, that will keep on moving in that one. But this momentum comes to rest, zero becomes zero. This continues with the same momentum. So if you see the diagram, after it hits the lower block, after this lower block hits the obstacle, then this the situation is there. So this suddenly come to rest, but this m mass starts moving with this velocity. This the velocity starts moving with the velocity f l by m. I can call this the initial velocity or u. And it travels from here to here, and this length is given to us as the L by 2. This length is L by 2. And from here to here, as it's coming, at that time, what forces will be acting on this? As now, this come to rest and this starts moving. So there is this is sliding over this one. So now kinetic friction will act. Till the time between these two blocks, static friction were acting between these two blocks, and that was internal force. But right now, between these two blocks, kinetic friction will act. That kinetic friction will try to oppose the motion of this speed of this one, and will act on this also, try to push this one, but this will be applying force. This obstacle will not allow it to go there. But friction is acting on the lower blocks also. So how much friction force will act on the upper block? We can draw the free body diagram of the upper block, and we can see that on the upper block only a force that is acting will mu mg is acting, because normal friction is mg. So on this kinetic friction mu mg is acting. So the acceleration of the upper block right now, F is equal to ma I put, and I cancel m and m, and I got the acceleration of the upper block after the lower block hits this is equal to this. A is equal to mu mg towards the left. So the situation becomes like this. So from this situation, the block has to attain this situation, right? What happened? There's the obstacle is there. From this situation, from here to here, the block has to travel. From this situation to this situation, the upper block will travel. It will L by 2 distance will travel, and during this time, the acceleration is acting in this direction. Velocity like this, acceleration acting like this. So again, we can apply our formula because acceleration constant quantity we saw. So v square is equal to u square plus 2a dot s. Will apply this formula. So initial velocity, that's what I calculated and put, and the final velocity by the time reaching is equal to 0. So those velocities, if I substitute here, then I can find out the velocities of the block is equal to v square equal to 0, u, whatever velocity I attain from this point. I calculated the velocities here. We have calculated initial velocity. This is the initial velocity. This final velocity is 0. Acceleration equal to mu g minus I cap, and s is equal to L by 2 I cap. So dot product will be minus 1. And from this, we can simplify these equations, and easily we got that mu gl is equal to fl by m. So this cancel. So from this, mu value can be calculated, and the mu value comes out to be equal to f is equal to, the mu is equal to f by mg. So we got the answer, f by mg, our answer. So now we calculated what the question is asked. Question is asking that what is the coefficient of friction. So now as a homework, you take this one, calculate, extend this question and calculate by what time it will come, the upper block, after what time, from starting from the most, from this position, if you start the stopwatch at this t is equal to 0, after what time it will reach the obstacle, after what time the upper block will reach the obstacle. From this to this time need to be calculated. The block has moved from here to here. So after what time this upper block will reach the position of the obstacle, that you need to calculate. Solve this problem. There's a we calculate all the acceleration, etc. Every parameter is given to you. You can solve this problem. Write the answer in the comment box after solving the problem. Hope you have understood it. If you have more doubts, you can send me to writefunda@gmail.com, and we'll be trying to clarify your doubts.